Talk to me in a minute, please. Alright, so, what? I'm going to do 2x firstly. So, whoops. 2x cubed plus 9x squared minus 24x plus 30. Okay. So, derivative 6x squared plus 18x minus 24 equals 0. I can definitely divide by 3, so 3x squared plus 9x, what's that, minus 8 equals 0? Yeah? No, sorry, this is wrong here, isn't it? Isn't it? Yeah, sorry. Alright. So what are the two solutions here?
1 and minus 4.
X equals 1. X equals minus 4. Yeah? And then what are the y's when you put them back in?
17, 1.
17 and...
142.
What is it?
142.
142? Okay.
Yes,
And that's...
y is wrong, doesn't bother.
Oh, it's the y is wrong. Fine. And you did put them back into this one, right?
Yes.
Good. Okay, so... Fine. It is this, yeah. So... Yeah, I know. So you need to know which one's the max and min. So second derivative would be 12x plus 18. So that's a positive when you put it in. And this one here would be a negative. So this one will be the min. And then this answer here will be the max. And they're both local. Neither of these are global. When you have a cubic, cubic goes up and down to infinity. So it's always local for a cubic. Did you hurry up and write this down, Mohammed? Did you write it down? So don't just stand there looking at me. Write it down. Sorry. Don't just sit there looking at me. Write it down.
6 divided by 3 is not 3.
It sure isn't. I like how you said it. 2, right? Yes. Well, that doesn't change these answers because you gave them to me, right?
Yeah, but
Then you can divide by 2 again. And so on. What?
Can I get 1/2 different answer?
What?
1/2 different answer.
Or?
Yeah.
What's the answer at the back?
Without minus.
Ah, what the heck? Yeah, that's wrong. It should be minus 8 sine.
Which number is it?
8 cos minus 8.
Oh, no, sorry. Yeah, it should be minus. Sorry, there's a minus missing in the answer. For or. 1 or. You got minus? It must be right, so. Yeah. Yes. Alright. Next one now. Number 16.
Just here when x equals 0, there is no answer.
What do you mean that? What?
Why?
X equals 0?
Yeah.
What do you mean there's no answer?
You did only one answer for y at the back, but there is 2 answers. You need to say 0, you didn't write.
Why did you get 2 answers though?
Because there is no.
But how did you get 2 answers?
152.
That is linear, not quadratic.
Minus 152.
Minus 2x minus 16
0.
equals 0. Is that linear or quadratic? Where's the square? It's linear, isn't it? It's calculator, no.
So how do I?
Wait, hang on, Amjad's annoying me.
Yes.
Minus 2x. Yeah? What's next?
Minus 16 equals
Yeah?
0.
Equals 0. Yes, you should be. Right, I'm going to do 16 now. So y equals minus x squared plus 10x plus 8. When is it decreasing? So it's decreasing when the slope is negative. When the gradient is negative, it's decreasing. So you get minus 2x less than minus 10. So you get x more than 5. Please, no moisturising in class. Thank you. Do you have this taken down?
Did you flip it because it's minus?
Correct.
Could we write infinity and 5? I mean, what is the
Should be 5 infinity.
why exactly?
Because if I say x is more than 5, it means it's between 5 and infinity.
I have a question.
Yes.
If I don't put the infinite sign for my answer, what is the point?
No. If you stopped here, it's still full marks.
Okay.
Okay. Now, we'll look at the next topic now, and it is, students find this quite difficult. So, I know from past experience it'll probably take the double class to do this, okay? So we're going to have a look at 85. Yeah. Now, Andy, behave yourself, okay? Have a very stressful day.
Page 85.
That's right. Hammer. Focus here. Right. So, like I said, we're nearly finished. There's this topic, and then we start integration. And integration, well, there's one more topic, and then we start integration. So this one here is all about practical problems. So if you remember, at the end of trigonometry, you did practical problems. At the end of sequence and series, you did practical problems. At the end of exponential and log, you did practical problems. So likewise with calculus and derivatives, there's practical problems. So what type of practical problems can you solve with calculus? You can solve what's called optimization problems, which means you can solve problems that help you work out where is the maximum and where is the minimum. So we'll have an example to start with, okay? So I'll write it down. So a cannon, well here. So in question 1, a cannonball is fired into the air, and the height of the cannonball is given by the formula 100t minus 5t squared. So this is the height of the cannonball. So for example, when t is 0, what's the height? 0. And then when t is 1? 95. So what's going to happen is it will increase in height, reach the top, and then start to fall back down. So we would like to know, when is it at the maximum? So that means if we want to find the maximum, just like in the previous lesson, we have to calculate the derivative. And then make it equal to 0. So therefore, t will equal 10. What's wrong? What's wrong? Did I do something wrong?
5 and you said 10.
That's right, isn't it? Yeah. 10 seconds. What is wrong? Right, 1 second.
This 10 or 100, 100. And H equal 100.
It's written right in front of your face as well. It does say 100t minus 5t squared, doesn't it?
Double checking.
Right. It's right. So I get t is 10. And I would like to know the height. So what do I do to find the height? Replace it back in here. So that is 1,000 minus 500. So 500 meters. That's the maximum height it'll be. So I don't say meters? All right.
It's not easy.
Yeah, so we don't need to worry, right? It's a short one to get started. Okay. Now, the next one. So what I'll do is, I'll do the second one, and then I think we'll start to alternate. So what I mean by that is, I'll let you try, and then I'll do the answer, and so on, okay? So, number 2 now, which is, this is more like a section A type of question, now a section B type of question, which is number 2. I don't know how you could be tired, Amber, after all that rest you had from not being in school, right? You should be fully charged up. Right, number 2 now. So if you read number 2, it's probably the one that says a company wishes to build a cylindrical can, is it? Or can of cola, whatever. And the can of cola needs to hold 330 cubic centimeters. Yeah. And then I probably said, did I say how much the metal is, or I didn't give the price? 0.03 pence per square centimetre, per 1 centimetre squared.
And 0.01 pound.
I just make sure I got it right. Yeah, 0.03. Yeah, okay, that's fine. That's fine. That's all I need to know. Okay, so in this problem here, you want to make can shape, and you need your can to hold 330 cubic centimeters of cola. So it needs to be, what do you probably use milliliters, don't you, for chemistry? Have you ever used milliliters in chemistry? Yes. No, yes, but you've seen a milliliter before, right? Why do you make things difficult for me? I don't know. So we need the volume here to be 330 centimeters cubed. And we know that 1 square of metal costs 0.03 p. Where 1 penny, of course, there's 100 pennies in a pound in the UK. Or 100 cent in a euro or whatever. Anyways, our goal is to make the cheapest can possible that will hold 330 centimeters cubed. So the first thing we write down is the formula for volume of a cylinder. And if you forgot it from middle school, here it is here. Pi r squared h. Or h. Write it down. If you forgot it, write it down. That's one formula. Now, if I want to know how expensive this can is to make, I need to work out what's called the surface area. The surface area. And that formula, again, if you forgot it, is 2 pi r squared plus 2 pi r h. These are all these middle school geometry formulas you need to learn, you know. So you have the volume of a cylinder, you have the area, then you have a cone, cube, all of them. Yes? No, it is not. Sorry, you've got to memorize them. You should have had them memorized from middle school. Yep. So no, not memorized. What's that?
Can you memorize your middle school?
I'll tell you something. You won't believe me, but this is true. I remember my very first maths class. Right? It was in the kitchen in my house. So yes, I can remember middle school. Right? Sorry to tell you this. Right, so my moral is you need to have these remembered. Now, if you look at the second one, that one there would give you the cost. Because remember, 1 square costs 0.03p. So for example, if I scroll to the side for the moment here, here's a 1 by 1 square, that will cost you 0.03. If you have this, how much would that cost you? 0.03 times 4. And the 4 is the area. So if you want the cost here, you just take the area and multiply it by 0.03. So here the cost will equal 0.03 multiply 2 pi r squared plus 2 pi r h. So if I want to find the minimum cost, what would I have to do? How would I find the minimum cost? Yep, first derivative and then what? Make the first derivative equal to 0, yeah? So what's the variable here? What is like the x? But don't forget there's also the h. So you see the problem here is that there's 2 variables and you need to have only one. So either the r or the h needs to be replaced. So let's replace the h because there's only one h to replace. So how could I find a formula for the h? Well, there's one formula I haven't used yet. What one's that? The volume here. What's the volume should it be? 330. So if I scroll a bit to the left, you can get here. Oh, actually, maybe I'll zoom out. Yeah. So here you can get but h equals 330 over pi r squared. And you can put that in for h. Yes. That's pi r squared, yeah. It came, this one came from here. Amber? No, leave it open. Fresh air is good. It'll prevent you from falling asleep. Yeah? Not just you now. There's other people too. Right, MD? Cost equals 0.03 2 pi r squared plus 2 pi r h, which is 330 all over pi r squared. Yeah. So what's nice now is there's now only one variable, r. So you can get cost equals 0.03 times 2 pi r squared. Pi's cancel, r's cancel. 660 r to the power of minus 1, because it'll be 1 over r. Now we can differentiate and make equal 0. D cost, no, sorry. Oh yeah, that was right. D cost dt, dr. Now, You don't need to worry about constants in the front, so you can just ignore that for the moment. So this would be 4 pi r minus 660 r to the minus 2 equals 0. Yep. It's okay? So, make this equal to 0. That must mean that 4 pi r is equal to 660 r to the minus 2. So, in other words, 1 over r squared. So, we bring the r squared up to the left and the 4 pi down to the right. So, you get r cubed equals 660 over 4 pi. So then, r will be the cube root of that. Can you please type that in carefully and tell me what you get? Yeah? Give me that too. No, give me. No, I do trust you. It's for the next part. So you got r is 3.7449, so 3.75. Now, how can you find the h? Well, you had a formula earlier, didn't you? Where's it gone? There. H is 330 over pi r squared. So here, h would be 330 over pi r squared. And you know the r now. So that would equal 7.49. This is gone and became a cube root, yeah. That's not entirely finished because I know to make it as cheap as possible, this is the radius I use and this is the height I use, but I still haven't told you what the cost is. Well, we have a formula for cost right up, like right here at the start. So I'll type it now at the bottom. Maybe you can just read it out to me. What was it? Cost equals 0.03 at the very beginning. What was next? Brackets 2 pi. Okay, so it'll be 2 pi r squared. Yeah, what's next? 2 pi r h. So let's see what we get for that.
7.95.
What did you get?
7.95.
Let's have a look. Yeah, that's equal to 7.95p. Or if you want to write it as pounds, 0.0795 as pounds, but not necessary. So what I can tell you is this. If you use any height and radius that is not equal to this, then you will be paying more than $7.95 per can. This is the absolute cheapest can you can make, which will hold 330 cubic centimeters of cola. You can't make it any cheaper than that. And the only way you could make it cheaper is if you made it smaller, it didn't hold to 330 cubic centimeters. But that's the cheapest dimensions you could use. How realistic is this? Well, there's one extra change I could make to make it more realistic. I said that the cost is 0.03 pennies per centimetre squared. And that's true, but when you think about a can of Coke, the metal on the side is quite different to the metal on the top and at the bottom. So to actually make it more realistic, you should do the cost equals the cost of the top plus the cost of the side, rather than like what I did, which is one continuous one. So this would be maybe more accurate for something that is, the metal is more uniform, like a can of peas or a can of beans or whatever. But with a can of cola, you know, the top, I think, is actually, it seems like it's thicker than the sides. And also on the top, you need to have the cap as well, makes it more expensive. And it's curved also. These things make it more expensive. So if the top is more expensive, how do you think that would change the shape? Will the cheapest can become taller or shorter, if we can picture? Well, yeah, why taller though? That's it. If the can is taller, then the tops will be smaller. So if you look at a can of Coke, it's not quite this dimension. 3.75 radius and 7 centimeters actually makes it about the same height and the same width. But you know a can of Coke is a little bit taller than this, right? And that is because the top and bottom is more expensive than the sides. Yeah? I don't understand why you could find this okay, but then other things you can't. You make no sense. So what we're going to do now is we're going to we're going to take turns here. So what I'll do is I'll leave you for a couple of minutes to try the next one, then I'll give you the solution. And we'll keep going through it like this, okay? So if you try, what number is this now? That was 2, so if you can try number 3. Yeah. Oh, sorry, what's another question here? Wait 1 second. No, I'm speaking for I can't leave it. It's in Sylvia's office, and Sylvia's not here, so you have to get it tomorrow, okay? Hey, get working fat tomorrow. Yes.
Why did you use Rubik Cube here?
Because it was originally R cubed. See the tree at the top. Yeah, here.
Oh, this is 3 hours.
Yes. Here, let me pause this. Now, look up. So, just... No, sit down. No, you'll distract me, sit down. Hurry up. Now, before I do the answer to the next one, there's one tiny thing I forgot to do in the last one, and that's just make sure it's a minimum. So what should the second derivative be if it's a minimum? Positive or negative? Negative. So if I go back up here, derivative again will be 4 pi. It should be positive for a minimum, okay? Derivative again will be 4 pi plus 660 multiplied by 2, or power minus 3. So it'd be, zoom out. Where's it gone? Yeah, 4 pi plus 660 times 2, or to the minus 3. Now, I don't even have to put in a value for or, because this is definitely positive. And this is definitely positive. So it's for sure positive, which means it's a minimum. Now I'll go on to the next one.
Should we write this one now?
Yeah, please add it to the answer to the last one. You just need to write it. That's a minus 3. Power minus 3. Yeah, please build me a Coca-Cola can with negative radius. That'd be great, thanks. Fill it up with some negative volume as well while you're at it, okay? First try to think realistically, then think mathematically, okay? Yes? Zoom out!
Go up.
What? No, what? I took the derivative here.
Yeah, the 0.03.
Irrelevant, because If I multiply a positive by a positive, it's still positive. And I multiply a positive by a negative, it's still negative. So a multiplication by a positive is not important to me when the only question I care about is if it's positive or negative.
So the D now gone.
The what's gone?
0.0 now gone. No.
It's not gone, it's just I don't care about it.
So I have put it in.
Right, next one. So you want to build a fence and you have 100 meters to build the fence. So the shape will look like this. A wall. You want to build a wall and you have 100 meters, okay? So we'll call this L and W. Better? Right, so you want to build a wall. In total, you have 100 meters. This means that W plus L plus W plus L should equal 100. So that means 2W plus 2L should equal 100. So W plus L should equal 50. By the way, Andy, in this question, this is called the constraint. You want to make the wall as big as you can, but you only have 100 meters of material. Okay? Is that okay so far? Now, what's the area here? L multiply W. And you want to make maximum area. Which is the variable here? L or W? Well, they both are. So one of them needs to be replaced. So here I can say, for example, L equals 50 minus W, and I can put that in. So I get 50 minus W times W, which will be minus W squared plus 50W, and that's the area. Now, how can I make the area maximum? Derivative. So that would be minus 2W plus 50 equal 0. So what will W equal? 25. Got that? If I put 25 in here for W, what will L equal? 25. And if I put L and W in here, what will A equal? 625. Yes. So this is if you want to use it in meters, okay, it'd be meters, meters, meter squared. So interestingly, if you want to make a garden or a wall, so if you think about it, if you look here, you want to make a garden. You want to make the garden as big as possible, but you don't want to spend a lot of money on the brick wall going around it. So this is if you have only 100 meters of bricks or fence or whatever, this is the biggest garden area you can make. So if it's not a square shape, it'll be smaller than that. And in fact, the same idea applies in 3 dimensions as well, okay? So if you have a piece of paper, if you want to make a suitcase, then the cheapest suitcase to make would actually be a cube. But how many people have cube-shaped suitcases? Me. You have a cube-shaped suitcase?
No.
Cubed? You know cubed? Yeah. But you don't. You have a rectangle-shaped one, don't you? You have a sphere-shaped one? Yeah, circular, is it? Anyways, that's the next one there, okay? So what's after that? Oh, wait, no, hang on. Again, one small thing to do at the end here. I want to make sure it's maximum. So what should the second derivative be? Minus 2. Okay. That would equal minus 2, which is negative. So therefore, this is maximum area you can make. Okay, let me pause that there. Yes, For sure. For sure. All right. Yep. Okay. So 4. Now, when the price of coffee at a coffee shop is €2, the demand is 100. So if I draw a graph like this, okay? Demand.
No, I don't understand. I mean, demand need for the cup of coffee.
Yes. So I'm explaining. Just listen. So when
I'm talking to myself.
that's even worse. So when the price is €2, 100 people will want to buy coffee when it's €2. But when the price is, so I should actually, sorry, I'll draw this a bit more over here. Oh, come on. So let me get rid of that. Sorry. So when the price is €2, 100 people will want to buy it. But when the price is reduced to €1, 150 people will want to buy it. That's not surprising. As you increase the price, you would expect less and less customers. So in other words, when the price is 2, the customers are 100 in total, and when the price is 1, you'll get more customers, 150. So if you think about it, there's 2 complicating factors here. On the one hand, you would like to increase your price. Why would you like to increase your price? Well, you would like to make more money. But then on the other hand, as you increase your price, you start to lose customers. So if we take an extreme example, if you set your price really high, you will get no customers and make no money, obviously. But if you set your price really low, you will make no profit, and likewise you will get no money. So there must be somewhere in between a low price and a high price that gives you most profit, most money. So that's the concept here. So we're clear on that. So let's have a start on it. So the first one is, this I call Q. Q is the number of customers, and this one here I call P for price. So what type of relationship do we think we have here? We'll say a linear relationship. Straight line. So as price goes up, Q goes down. Now, semester 1, week 1 is, if I give you 2 points, 150, 2 100, we can find the line that connects them. So first I'll find the M. So M would be y2 minus y1 over that. So the M would be minus 50. Is that okay so far? This is just week 1 stuff. So I have now Q equals MP plus C. And how can I find the C? Use a point. So I'll use this point here. So I get 150 equals minus 50 plus C. So what will C equal? 200. So that's our first result. Q equals minus 50p plus 200. So what I want you to notice, what is the Q if the price is 4? What's the Q if the price is 4? Tell me.
4 multiplied by 50.
Yeah, so work it out, look at it. Be 0 in total. Minus 50 times 4 is minus 200. Minus 200 plus 200? So if the P is 4, the Q is 0. So that means at €4, nobody will buy coffee. Okay? And then what happens if, for example, the price is 0? How many people will buy coffee? 200. Yeah. Yeah. Now, well, it won't actually ever be infinity because, you know, there is an infinite number of customers. Even when something is free, there's still a finite number that will visit your store. So here it'll be 200. Okay, so that's part one. Part one is find the relationship. Now, part two, we have to find out what the total cost is. So there's a tiny little bit of what you might call economics or business here, okay? The total cost is equal to the fixed cost plus the variable cost. What I mean, if you think about it, all right, if you think about this classroom here and how much it costs to do a class, there's two expenses. The first expense is you must pay to rent this room. Okay? That's the first expense. And does that number change? It does not. So if I had 1 student or 100 students in here, that fixed cost is the same. The variable cost is the cost per customer. So for example, that maths book there, each time I print that maths book, that's a cost per student. So for a coffee shop, the fixed cost would be the cost of the rent, whatever it is. So what's it here? 70 euros per day. And the variable cost, what would the variable cost be? Yeah, but what would it be? Just tell me. The actual cost to make the cup of coffee per customer. And what's that here? 0.33 euros per coffee. So if you just multiply that by how many customers you get, 0.33 Q. That would be the total cost then. Yes? Okay, fine. What? It's add, yeah, that's a plus.
And the question also wrong.
I don't know how a question could be wrong, but okay.
You say in terms of fee.
Where? Which one, Andy?
In terms of fee. You say in terms of fee.
Yes, that's right. I'm not finished yet, Andy, because I'm being interrupted by a student.
But the answer is this, behind answer is this.
Fine, the answer at the back then needs to be fixed, but the question's not wrong. Continuing. So, this is the total cost. Now, I don't want Q in this formula. Because the reason I don't want Q in the formula is the Q I do not control. I cannot control how many people come into the store. What do I control? The price. So I replace the Q here. Okay? Now, can you please... Oh no, I'll do it. I'll do it. Minus here, okay? Is that okay? Is that fine?
Yeah.
All right. Is that all okay? 67. What's only 66? Here?
Yeah.
0.33 times 200 is that? 66.
Yeah.
0.6. Okay, sorry. It's no point there, is it? Alright, so I just need to get rid of this bit here. 66 just, yeah?
Yeah.
Okay. And then, so I'll just change that there. So it's probably just 136?
Yeah.
Okay. 136 minus that. So, if the price is 0, Amjad, just look up. If the price is 0, what's the total cost? 136. And then as the price increases, what happens to the total cost?
It's going to decrease.
It goes decrease. So something, hang on. Should be a minus here? Yeah, no, that's right, yeah. Yeah. So if you look here, 70 is how much it costs for rent. 0.33Q is how much it costs to make the cups of coffee. What's the Q? We got a formula, is minus 50p plus 200. So remember, when the P is 0, then you have 200 people wanting to buy coffee. And when the P is 4, then you have 0 people buying coffee. So think about this. If the P is 4, if you put P is 4 here, your answer will come out as 70. Why will that be? What do you think?
Because you'll substitute P.
Hang on, one at a time. So what do you think?
You'll substitute P with the first value there.
Yeah, but I mean the more explanation. Yeah, that's what I was thinking of. You don't have customers. If you have P is 4, how many people will buy coffee? No. So your cost will just be the cost of the rent, which is 70. Yeah, and that's the worst case scenario. Okay, and then as the P increases, then the cost actually goes down. Which also, when you think about it, makes sense. You know, as a business gets bigger, then it might get, you want your business to be big because it'll be cheaper to do business then. Like, for example, it'd be quite a serious problem if you just had one student here, because the cost would be the cost of the room plus one maths book. Yeah? So, that's the cost there. Right, so that's the next part. Now, the next one is the revenue. What, does anyone know what this word means, revenue?
No.
Revenue just means the sales. Sales, okay? So if you have Q customers and each customer pays a price P per coffee, how much money do you make? What do you think? So think about it. If the coffee is €2 and you have 100 customers, for example, how much money did you make? 200. Now how did you get that number? Just multiply the 2. So then total revenue, how much money you make, that's the next part. That's equal to PQ. And what do you think again we replace? We replace the Q as well. So P times minus 50p plus 200. So we'll get minus 50p squared plus 200p. Now, doesn't take too much thinking here. If the price is 0, how much sales do you make? How much money do you take in if the price is 0? Unsurprising. But also notice, if you put the price here as 4, okay? So 4 squared, 16. 16 times 50 will actually be the same as this number here. So the total you get is 0. So why do you get no money if you set the price as 4? Because again, you get no customers, okay? So you want somewhere in between. Right, so, yes. That TR, total revenue, total sales. Okay. Equal here. Yeah? Okay, D now. So finally we're getting towards getting to the answer. We want to work out the total profit. So, profit, what would profit be? No, stop rambling. Profit will be what? No, what's the formula? What things do you subtract? Your sales minus the cost. That's your profit. Right? Yes. So, can you read it back to me? What was the... Oh, there's the TR formula. Okay, and what was the TC formula? 70 minus... It was minus here, wasn't it? No, I'm talking about... I want this.
It's minus, yeah.
I want the simplified one.
Minus 16.65.
Alright, so that is the formula for total profit. Okay? We can clean this up a little bit. So you get minus 50p squared, I'll type it in, 200, well, it'd be plus 216.65p minus 136. Yeah? That's your profit. The fact that this is minus here is actually important because, again, if you set the price as 0, how much profit do you make? Minus 136. So you're making a loss. Yes, you're paying 136. What shape is this? Concave or convex? Concave. So it has a maximum. So there's some price that you can pick that will make this profit the maximum profit you can make. And no amount of changing of the price will get you more money. So, what do we do now? Derivative. Minus 100p plus 216.65 equal 0. So p would equal 2.17 about. So this, in fact, is the best price you can set your coffee at to make the most money. If you increase it past this price, you will get less customers, and it'll mean less profit. But if you decrease it below this price, although you do get more customers, it's at the expense of profit. Okay? So I mean, it's important because you might just think the simplest way for a business to make more money would just be to increase the price as much as possible. But in fact, you can imagine this weird situation. Imagine this coffee shop was selling coffee at €3. Okay? It's selling coffee at €3. What would happen if it dropped this price to $2.17? Would it make more or less money?
More.
Would make more. Now just think about that for a moment. It drops its price and it gets more money in the bank. The reason for this is because when it was selling at €3, it was selling it past the optimum, past the maximum. So in fact, the decrease actually gave more money. Yes? Now, I just want to make one other point which is similar to this. And the same goes with tax as well. I will, hang on, Hammer. The next time you look out the window, you will be going out the window.
It's cold.
Then just move to the end of the table. You will do that in a moment. Okay. I'll go back to this, but I want to give you another important example. Not without numbers, just with the graph. Okay. So if you think about this, as a government, you want to make as much tax as possible, okay? So here is how much money the government gets as tax, and here's the percent you charge people. So for example, in Ireland, sales tax is 20%, income tax is 25%, about 20-something percent, okay? There's different percent. Anyways, if you set your tax at 0%, how much money will you make? Nothing. So if the government has 0% tax rate, then of course it gets no money. And what happens if it puts it at 100%?
Everyone's going to live out of it.
True. But how much tax will it take? Now see, this is it. If it's 100%, it will take 0 also. Because this might come as a surprise for you, but if the government took all my salary in tax, I would not be teaching you right now. Right? Because I would not do it for free.
That's what's happening in France right now.
And this is a problem in France. So if you increase the tax rate too much, then people won't bother to work because there'll be no point for them. And the extreme is, if the tax is 100%, that means people get no money, so they will not work. So just like with the coffee shop, there is some tax rate in between the two extremes that gives you the most money. So as you're saying, Steve, I think actually in France, I suspect that they probably have the tax rate too high, and actually if they decrease the tax rate, they might actually make more money. I know this has happened at least once recently, I can't remember the country, where they decreased the tax rate from 25 to 15%, and you might think they will take less money, but in fact they ended up taking more money. Okay? So it's just like with the coffee shop. So maths, it's important. Yeah?
So this is the price they make.
So this is the best price they can set their coffee at for maximum profit.
What about if there is no tax, like my country don't have tax?
Then the government will make no money in tax. Yeah? So, I'm going to do now number 5. So, number 5, express the number 8 as a sum of two numbers such that the result of multiplying their product by their difference is a maximum. So, in other words, MB, you really better be quiet or out you go. No, just smile, nod, and say, yes, teacher. You're good. Right. 5 now. So, express 8 as the sum of two numbers such that the result of multiplying their product by their difference is a maximum. What? So I'll read it again, listen carefully, and I'll highlight the parts I wrote down that match with the question. So watch carefully. Express the number 8 as the sum of two numbers such that the result of multiplying their product by their difference is a maximum. Yeah?
X minus y is different of x plus y.
Yes, it is. So, you have this, and you want to make this a maximum. The problem is there are two variables. So you need to replace one of them. Which one to replace? It doesn't matter. So you can say 8 minus x equal to y from here. Okay, so here you get x times y times x minus y. So that's x times y multiply x minus y. So minus that. This becomes x times 8 minus x times 2x minus 8. That becomes 8x minus x squared times 2x minus 8. Okay, there's an x there. There's an x on the left, okay? That's an x there off the screen. Right, so let's multiply this out. So we get 16x squared minus 64x minus 2x cubed plus 8x squared. So you get minus 2x cubed. How many squareds now? Plus 24 in total, yeah? X squared minus 64x. Now we're in a position to find the maximum. So to find the maximum, we make the derivative 0. So that would be minus 6x squared plus 48x minus 64 equals 0. Let's see what we get. Minus 6, 48, minus 64. So you get two answers. The first one is x equals 6.3, and the second one is x equals 1.7. You can sub them in to get the y. So y will end up being 1.7, and the y here would end up being 6.3. So you have two answers. But when you pause and realize and think about this, they're actually really the same answer. So in the first case, I have 8 equals 6.3 plus 1.7, or 8 equals 1.7 plus 6.3. It's just the opposite way around. So what does that tell us? These are the two numbers that add to 8, so that when you multiply their product and difference, it's a maximum. Yes?
Can you read the total?
All right, from the top.
And the second derivative?
In a moment, please. Time. Right, so I'll run through this one more time. Listen carefully. Right. Write 8 as the sum of two numbers, so that's that part there, so that the result of multiplying their product and their difference is a maximum. So we want to write 8 as two numbers added together, so that when you multiply their product and difference, that is a maximum. Here there are two variables, no good. We can use this here to replace the y. So replace the y, multiply, simplify, differentiate, equals 0.
What is plus x?
Where plus x?
Minus 8 plus x.
Here.
No,
Here.
the top one.
Here.
No, no.
Here. Here.
No, because they already got the value of x.
Substitute, Amjad, substitute. Watch. Here is xy. This is x and this is y. And here is x minus y. So here is x and here is minus y.
Oh, minus.
Yes. Now, we have to do the second derivative now to make sure it's a maximum. So if the second derivative is to represent the maximum, should it be a positive or a negative? Should be a negative. So look here from this line. That's the first derivative. So what's the derivative again? Minus 6x squared plus, I'll go to the right here, plus 48x minus 64. And I feel confident in telling you that when you put the x's into this, they'll come out as negative. But I don't think I asked you to check that in the question, so it's not such a big deal. But you can check that it's a maximum by making sure the second derivative is negative. Yeah? Right, listen carefully. I absolutely want 6 and 7 done for the next class. And listen. I'm telling you this now. I have spent 2 classes looking at these. I am not going to spend any time in the next class doing 6 or 7. So if you have trouble doing 6 or 7, it's your responsibility to find somebody in the class who could do 6 and 7 and copy the answer from them.
Do you have it in Moodle?
No, I don't actually. I don't have it in Moodle. Now look. Hey, wait. If the situation comes up that nobody, not one person could do 6 and 7, I'll consider doing it at a later date. Yes. I'll check next time 6 and 7.